Okay, so we started with probability distribution. So before going into probability distribution, we have to discuss first about the random variable. So a random variable is a set of possible values from a random experiment. Okay, so set of possible values from a random experiment. See, we can perform any experiment. That particular experiment will have some outcome. So we will assign some values to those outcomes. Okay, those values what we assign to those outcomes will be called as random variable. So how we will do that, we'll see here. So tossing coin, we get head or tail. Fine. So let's keep head is equal to 0 and let's keep tail is equal to 1. Okay, Vijay?
Yeah.
And then we have random variable x. So we have random variable x in what way? So I'll show you that. So let's take random events. Random events, like you have a coin here. Okay. And you tossed a coin. Fine. There are two values. There are two outcomes it can have. So for those outcomes, we have given some values 0 and 1. So random events, possible values 0 and 1. Okay. And then if I have to say, what is this? I can say random variable x, correct? So random variable here is x. I am denoting the random variable with x, with letter x. It can take any of the values 0 and 1 when I toss a coin. Okay. So if I get 0, that means head. If I get tail, that means 1. Understood? So can I put x under this flower bracket 0 and 1? Can I do this?
Yes, you can. Yeah.
Yeah. So here, like this is what is random variable all about. So when we toss a coin, it's a random experiment. There will be an outcome of that. That will be an event. Outcome can be either head or tail. For those head or tails, we have assigned some values 0 and 1. And those values what we have assigned, we are saying that it's a random variable. So that makes sense, correct?
Yeah, that makes sense.
Now let us take some example. What is the sample space? Sample space is nothing but all the possible outcomes from a particular experiment, isn't it so? That means if you take a die, what is the sample space if you take a die?
1 to 6.
1 to 6, okay. For a die is like 1, 2, 3, 4, 5, 6. This can be the sample space. Now we will see the probability of this, and that will be nothing but the probability function. So probability function is nothing but equal to distribution function. I'll tell you what is distribution. Before going into distribution, we'll discuss about the probability function. Okay. So now let's see if I take probability x taking some value. Probability x taking some value that is equal to probability of that value, correct? That means if you take some random variable x is equal to 1, 2, 3, 4, 5, 6. These are the random variables. If you throw a die, you can expect all these 6 outcomes, correct?
Yes, of course.
And for these 6 outcomes, there can be some probability.
Yeah, there is a probability. Yeah.
So probability of x is equal to value means probability of x being 1 is what? Probability of x being 2 is
1 by 6.
Probability of x being 3 is?
That's the same.
X being 4? X being 5? X being 6? So now I have all the probabilities, okay? And I have also, I have to see if all these probabilities you can see, can I say this is a probability function? Can be denoted as probability of p is equal to value or probability of capital letter x is equal to small x. That means capital X taking some value, correct?
Yeah.
So capital X, that is random variable, and that random variable is X here. So X being 1, we are putting in this and we are getting what? 1 by 6, correct? So that is the probability, and this is the probability function, correct? So this probability function can take any like expression. We will come to that afterwards. But as far as this is concerned, it is clear, correct?
Yeah.
Okay, let's go forward now. So now we will first discuss about the distribution. What is the distribution all about? Okay. Now, a probability distribution is a tabular representation, you can say. It can be a tabular representation. It can be a function in an equation manner. Okay. So generally, when you go for like when you study mathematics, mathematicians generally use equations. Okay. When like the experiments are many and the outcomes are many, but when we have like when we perform a casual experiment and the outcomes are less, we can go for a tabular representation also. Okay. So probability distribution is a tabular representation or pictorial representation of the probability P of X for any value of X. Okay, so probability X is equal to X. That's what we discussed, correct? Now, suppose you take 2 coins. Okay. So when you take 2 coins and you flip it, what are the outcomes, Abhijit?
50-50.
No, I'm saying 2 coins, not 1 coin. 2 coins, head, 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 tail, tail, head, tail, tail, correct?
Yes.
So these are the like 4 things, and these are the possible outcomes of 2 flipped coins. Now I will ask you a question. I just want to show the for the heads. Okay, I just want to show the number of heads, fine, and their probabilities. I want to show number of heads and the probability of those heads occurring in a tabular representation. So what will that be kind of? So it will be like this. So I take some random variable X. That X represents number of heads. Okay. So number of heads, we can start from 0. Okay, we can start from 1, and the final number of heads what you're saying is 2, correct?
Okay.
And then if I take the probability of X, the random variables, so these are the random variables, correct?
Okay.
Or let's say simply probability of X, the probability of 0 heads. So what is the probability of 0 heads in this? This is the case whereby you don't see any heads, correct?
1 by 4.
1 by 4. And the probability of 1 head, 2 by 4. That is 1 by 2, correct? And the probability of 2 heads, that is again 1 by 4. Okay. So the probability comes out to be 0.25, 0.50 and 0.25. And the sum of the probability should always be equal to 1. Does it make sense?
Yes.
So is it a tabular representation of the outcomes of a random experiment and their probabilities?
Yes, it's a tabular representation.
Yeah. So the outcomes you have given assigned a random variable, and those outcomes are here. you wanted to check the number of hits in this experiment and the probabilities you have assigned here. So that makes sense now. It is definitely a tabular representation what we are seeing about. We can also go for a pictorial representation in the form of a distribution. Let's say this one. And we take like number of hits in the x-axis. So let's start with like 0. This is like 0 heads, 1 head, 2 heads. OK, and the probabilities what we got is 0.25 and 0.50. So we put it like this. Fine.
Okay.
So what about the 0 heads? It is 0.25, correct?
Yeah.
So we put it here. And what about the 1? It is 0.50. We put it here. And then 2 again 0.25. OK, so what we'll try to do is we'll try to join them in this way. So this is a pictorial representation of this probability distribution. Understood?
Yeah.
You can make a note of this, Abhijit.
Understood. Yeah. Yeah, you can go ahead.
Okay. Now, what is discrete and what is continuous? Discrete is countable.
Huh.
Continuous, can you count?
No, actually I cannot.
Some example of discrete. The
Yeah,
example we took number of heads
yeah.
from toss. This discrete discrete observation or discrete variable. OK. And what about the continuous variables? Can you give some example?
Rain during.
Like we can take qualities, na? Can we count some? Can we quantify someone's quality? Qualities such as height,
Okay.
weight, temperature, distance. OK, so these are all the examples of continuous variable. So that can take some decimal values, like say 34.27 or 34.569, like that. So given in a range, it may take infinite values. Understood? And these are all countable ones. Fine. Now let's move forward. So one thing you should understand, the probability of discrete variable is somewhere around between 0 to 1. Understood?
Of course.
OK. And for continuous, I have already explained you what the case is. Fine. Now let's go into the textbook. So we have covered all this, Abhijit. Probability distribution, discrete random variable, probability function I have discussed right now with you.
Yes, we have. Yeah.
And we have discussed, sorry.
Yeah, you have.
Hello. Yeah, and we have already discussed that the probability of discrete random variable lies between 0 and 1, and sum of the probability is always equal to 1. OK, do this question, Abhijit. In this, hello, yeah, in this question, you can understand something. Consider, can you hear me?
Yes, I can hear you.
Consider the following function x is equal to 1, 2, 3, 4. So these are the random variables, and this is the probability function, correct? This is the probability function. So if we put these random variables in this probability function, OK, Can we get the probabilities of these random variables?
Yeah, you can. Yeah.
So you can put that in the function and you get this probabilities and the sum of the probability is equal to 1, correct?
Okay.
We have already discussed about continuous random variable. We have discussed about the discrete function, continuous function. Discrete is like for a discrete distribution whereby you can count the variables where like probability of x is equal to 0 when x cannot occur. Okay, when x cannot occur, we put x is equal to 0. Isn't it so?
Yeah.
And like probability of x greater than 0 if it can, like see 1 2 3 4, if we take this random variables and we probability of x is equal to 0, that means it can take any number which is not existing in this like set, isn't it so?
Okay.
Probability of x is equal to 0 means something, we are finding the probability of something which is not there in this at all. That's the reason why we are getting probability as 0, no? Now, recall that probability of x is greater as the probability that random variable x is equal to x. X will take some specific value. So x will take some specific value here, 1. So we are finding the probability of x taking 1, x taking 2, x taking 3. Okay. For example, the probability of it raining on 33 days in June is 0. Because do you think 33 days exist in June?
No.
Never.
No.
That doesn't fall in this set at all, correct? But if I want to check for 25 days, it is possible. Yeah. And already discussed about the continuous distribution. Fine. So no need to discuss about that. Yeah. So in finance, some discrete distributions are treated as though they are continuous because the number of possible outcomes is very large. Sometimes, and when that can happen, let us see this example. This will help us to understand. For example, the increase or decrease in the price of a stock traded in an American exchange is recorded in dollars and cents, correct?
Yes.
The increase or decrease in the stock price of stock, they show in terms of dollars or cents. Yet the probability of a change of exactly 1.33 or 1.44 comes in decimal values, correct? Or any other specific change is almost 0.
Okay.
Do you think any reasonable change in this? The probability exactly, it's like almost 0 change, not negligible change. So it is customary therefore to speak in terms of probability of a range of possible price change, say between $1 and $2. In other words, price change is equal to 1.33, essentially 0, because like we are taking in terms of $1, correct? The difference we are taking in terms of
$1.
yeah. So in other words, price change is equal to this is essentially 0, but price change between 1 and 2 is greater than 0. Why? Because we are considering in terms of $1. Understood, no?
Yeah.
That's one. When we consider in terms of $1, exact change we are seeing in like that should have a complete figure. But if you get these kind of figures, then that is not existing, isn't it so? So what is this cumulative distribution function? Cumulative distribution function is nothing but when I say about probability density function or something, probability that x will take some value x, but probability that x will be less than equal to some value, less than equal to some value. Okay, then I speak about what kind of function? Cumulative distribution function, correct?
Yeah.
So a cumulative distribution function or simply distribution function defines the probability that a random variable x takes on a value equal to or less than a specific value x. So when I say probability of x is equal to x, that means that is probability mass function for discrete variable I'm speaking. But like normally that is like a normal probability distribution function. When I speak about cumulative distribution function, that is nothing but x will take some value either equal to or less than x, correct? That means this random variable will take some value either equal to or less than x. Now, this capital X always represents random variable, Abhijit. Okay, and this random variable will the values will be given to you always 1, 2, 3, 4. That will take some exact value. For example, if I take x is equal to 1, 2, 3, 4. So this capital X is x, capital X here, correct? What is the small x? It can take 1, 2, 3, 4. Isn't it so?
Okay.
You understood now what I'm saying?
Yeah.
Probability of capital X is equal to 1. That makes sense now. Small x is these numbers, what we're taking under that random variable function. Now, so it represents the sum or cumulative value of probabilities for outcomes up to and including a specified outcome. So it may not cross, it may not be beyond this. It may always be either equal to or less than some value. That is what the cumulative distribution function shows. To understand that in a better way, we take a probability function that we are taking a random variable here, x 1, 2, 3, 4. And this is the probability function. So we put some values in this. Okay, the random variable can take these values, no? Am I right?
Oh, it can take those values.
Yeah. So if we take 3 here, for this distribution, f of 3 is equal to 0.6. How it is 0.6? We are denoting this cumulative distribution function with f of x, correct or wrong?
Yeah.
And like what we are taking here, if I am taking 3 here, that means I can take the values till what? 3, correct or wrong?
Yes.
So here x will take value either equal to 3 or less than equal to 3, isn't it so? So I'm
Yes.
considering all the probabilities less than 3 or exactly till 3. So I will take this 1 in the probability function. I'll get 0.1, 2, 0.2, 3, 0.3, and when I sum it, it becomes 0.6. That shows the cumulative distribution function for f being 3. Okay, that's what. And if it is f is equal to 4, or like if I want to find the CDF of f being 4 is nothing but I take all the values. That means the random variable x can be less than or equal to 4. Correct or wrong?
Okay. Okay. Yeah.
See, random variable can take any values. Now, when I take probability of x is equal to x, I'm taking a specific value. Probability of x is equal to 1. But if I'm taking CDF, I'm considering probability of x less than equal to 4. That means x being less than or equal to 4. Correct?
Yeah. Makes sense.
So that's what the CDF says. Correct? Now. So we will see the figure here. Figure 4.1 shows an example of cumulative distribution function for a standard normal distribution. So standard normal distribution is always used when you have continuous data. Okay. So there is a 15.87 probability of values less than -1. So the values to be less than -1, what is the probability? 0.1587, that is 15.87. That means it takes all these probabilities below -1, correct or wrong?
Okay.
The probability of there is a 15.87 probability of a value less than -1. That means if you want to get a value less than -1, it can take any of this space and the probability will be 15.87, correct?
The shaded region. Yeah.
Yeah, shaded region, yes. So that's what this CDF says. And we have to see here your probability density function, your cumulative distribution function will always be in this way. Why? Because you will have all the probabilities and the sum of the probability should be equal to what? 1. So it will come here and it will become flatter. Understood? Now.
I think we can move ahead. No? Hello.